This is the classic transmission wires, and then a question, and then it leads on to usually transformers as well. So we've got two transmission wires, each has a resistance of 2 ohms, so the total resistance of 4 ohms. This guy here wants to operate at 4 watts when there's 2 volts across the bulb, 2 volts and 4 watts. So they initially set their power supply to 2 volts because that's what they think the globe wants, but they find the globe does not glow as brightly as expected. Explain why. So the reason here is, this is a 2-mark question, is the first dot point is that the transmission lines have resistance. And because they have a resistance, there is voltage used in them. So 2 volts starts out here, there will be a voltage drop over these lines, so there's not 2 volts left for the globe. Therefore, voltage remaining for the globe is less than 2 volts. 15. The voltage supply is now set so that the globe operates at 4 watts. Calculate that required voltage and show you're working. So they must increase it. They must turn the voltage up from 2 volts to something higher. So hopefully our answer is going to be bigger than 2 volts. And what is that? What I'm going to do is down below in that question I'm going to redraw this but as a circuit diagram, just so it makes a little bit more sense. So the circuit diagram is there's a power supply, there's one of the lines, there's my bulb, and there's the other line. Now we've got 2 ohms, 2 ohms, and this wants 2 volts, and it also wants 4 watts. And we want to know what the total voltage is, that's what they're asking. Well, how would I go about working this out? Well, this is kind of my final calculation. What I'm going to do is I'm going to work out the total current. So the current through the bulb, we've got the power in the bulb, we've got the voltage in the bulb, and we can work out the current so P equals VI. I've just labelled it for bulb so you know what we're looking at. So if you rearrange that, you get I in the bulb is power in the bulb divided by voltage in the bulb, which equals 4 watts over 2 volts, which equals 2 amps. At 2 amps will go through there, 2 amps goes through everything now. 2 amps goes through all of this whole circuit. So we've got the current at 2 amps. Now we can work out the voltage in the lines. Because voltage equals IR. The current in the lines times the resistance of the lines. Well, the current's 2 amps because it goes through everywhere. The resistance, we can do it one at a time, but we can just put them together. Total resistance of 4 ohms. So the voltage in the lines is 8 volts. So now we can work out the total voltage. It's the voltage in the lines plus, because this is a series circuit, the voltage in the bulb, and that's just 8 plus 2, 10 volts. This is question, I think 16, 17. Alright, I've got the picture here again, so we can figure out this next one. This is the old question. Question 16. When the globe is operating at 4 watts as designed, with 2 volts and 4 watts, what's the power loss in the transmission lines? Power loss, as soon as you see that, it's always I squared R. I squared R. We worked out in the last question that I was equal to 2 amps, so this is going to be really easy now. 2 squared, and the resistance of the lines, there's 2 of them at 2 ohms each, so that's 4 ohms. So 2 squared is 4 times 4, 16 watts. Alright. One of the students says that the real situation, this power loss would be unacceptable. She observes that AC rather than DC is used for long distance power transmission systems. Explain why this is the case. Alright, it's only worth 2 marks, but we'll set those out in dot points. So really what we want to talk about is minimising this loss here. To minimise that loss, we want the current to be as small as possible, and for that to happen we need to use transformers, and transformers only work with AC. So let's see if we can get this in here, my explanation. So P loss equals I squared R. I can be minimised, and therefore power loss minimised if V is large. Now large V, large voltages are achieved with transformers, and transformers only work with AC.